Hi again. So we're having a look at the 2019 Heffernan Exam 1. That means that we're completing this exam without calculator and without a bound reference, and we're referring to question 5 and question 8A from this exam. Question 5 states, the random variable x is normally distributed. It has a mean of 20 and a variance of 9, and the probability of x being less than 29 equals q. The random variable z is the standard normal distribution. Find the probability of z being less than -3 in terms of q. The first part of this question, what I want to highlight here is the variance of x is given as 9. Therefore, my standard deviation is going to equal 3 because it's a square root of 9. What I'm next going to do just on the side here is I'm going to sketch the distribution of x, and I'm going to say 20, and then I'll have 23, 26, 29. That's 3 iterations away. And the area in here equals q. Then when I come to evaluate z, okay, so z being less than -3, what I'm looking at here is I've got my normal distribution, but this is a standard normal distribution. So 0, -1, -2, -3. I'll just extend that out a little bit. And that area there is equal to q. Now, we're not focused on finding that area. We're focused on finding this area, which I'm shading in green. Therefore, I can say that q, or the probability of z less than -3, is going to equal 1 minus q. And that's this area here that I've shaded in green. So I'll just put that green area just to denote it. All right. Then it says, find the probability of z being greater than 0, provided that z is less than 3. So what I'm going to do here, and it asks us to write it in terms of q, is I'm going to firstly write this as probability of z greater than 0 given that z is less than 3. And I'm going to use my conditional probability. So this is probability of z greater than 0 intersecting with z less than 3 all over the probability of z less than 3. Returning to my normal distribution, or standard normal distribution here. I'm going to firstly put in what z greater than 0 is going to look like. Okay, so that's going to be something that looks like that. I'm going to tell you that that area there is going to be 0.5. We should know that. And then we're focusing on z less than 3. And if I focus on that area, z less than 3, that area there should be equal to q. Okay. Therefore, we can say that the combined area here should equal, okay, q minus 0.5 all over q. And there we have our answer. Okay, so question 8, moving on, getting away from the probability. Question 8 says, let f 0 infinity r, fx equals square root of x. The graph of f is shown below. Okay, P lies on the graph. Okay, the point Q10 is a point. Find the minimum distance between P and Q. Okay, so we're looking at the distance between these 2 points. I'm going to call that D as an expression, and we're looking for, so D as an expression would equal, now one thing that I might do here is I might write that as square root of x, because that's what fx equals. And then we're going to use our distance formula here. So we're going to say x2 minus x1, so that's x minus 1 all squared, okay, plus square root of x, take away 0, squared. My distance here will equal x minus 1 squared plus x. So I'll just let you think about that for a moment. I might expand this out. So x squared minus 2x plus 1 plus x, and D here equals square root of x squared minus x plus 1. I'm going to have a look at D of the distance in terms of dx. Okay. What I might do prior to it though is write the expression in a form that I can easily use the chain rule. So that's going to be a half 2x minus 1 x squared minus x plus 1 to a negative a half dx is going to equal 1. I'm just going to put it all on this. So 2x minus 1 and then square root x squared minus x plus 1. We're looking for the minimum distance, therefore we're optimizing. We're going to make d dx. Okay, we're going to make it equal to 0. If I'm making that equal to 0, I want us to really understand that for that term to equal 0, the numerator is going to equal 0. So what I'm going to say here is that 0 equals 2x minus 1, which gives us a result of x equals a half. So when x equals a half, then we want to find the distance. So we found the value of x, but we want to find the distance. Okay, and the distance is x squared minus x plus 1. So this will equal square root of x squared, a half x, that's a quarter, minus a half plus 1. Okay, this is going to reduce to 3 on 4, which I can write as square root of 3 on 2. And I think the question asks us to have it in the form of square root of a on b. Okay, so this is in the form, okay, just note here, that's in the form square root of a on b. And that should be our answer. Okay, I hope that helps. Keep working. We'll keep on working as well.